Okay, good day everybody. This video will cover the first part of the chapter on interest rates. It's a video that covers material for an undergraduate course in corporate finance. In this first part of the video, we will be seeing APR, annual percentage rate, EAR, effective annual rate, and the effect of compounding over many periods. So the APR, the annual percentage rate, or generally the quoted rate by a provider of funds. What is it? So generally the banking sector is heavily regulated, and regulations demand that the provider of funds or any financial institution disclose the interest rate on its financial product in a clear and unambiguous manner. So the simplest way to quote an interest rate is to announce the simple interest that will be earned during a year. So the simple interest is the interest that prevails per compounding period times the number of these compounding periods during a year. So the simple interest on a credit card compounded monthly is the monthly interest rate times 12. The simple interest on a product that pays interest 4 times a year or every 3 months is the interest rate that is applied every 3 months times 4. Okay, so the annual percentage rate is simple interest that is earned during the year. So if a loan is if a loan is taken to buy a car carrying an annual percentage rate of 8% calculated monthly, so this means that every month the lender will apply the rate of 0.6667% on the loan, and so on the loan balance at the end of each month. So the quoted APR corresponds to 12 times 0.6667%, which gives 8%. A credit card carries an APR of 18%. What does this mean? This means that every month, whatever the balance is on the card company applies the rate 1.5% as interest on the credit card. So 1.5% is the interest per compounding period. How many of these compounding periods are there in a year? 12. So the annual percentage rate is 12 times 1.5%, 18%. So that's APR. Now the EAR, the effective annual rate. So the effective annual rate, so this is total interest paid during a year. So if a credit card quotes an APR of 18%, compounded monthly, so it applies a monthly interest rate of 1.5%. So at the end of the year, okay, how much will be paid in interest by the holder of the card? So how much will be paid in interest? It will be given by 1 plus 1.5% to the power 12 minus 1, because we subtract the value of the amount borrowed, like the capital. So the difference here will be equal to the total amount of interest being paid by the borrower. In this example here, so the term 1 plus 18% divided by 12 to the power 12 minus 1, which is 19.56%. This is the effective annual rate paid on the card during the year for an amount of money that remains on the card for a full year. So it's more than 18% because the holder of the card is being charged interest on interest as the months accumulate. If an investment vehicle presents an APR of 10% compounded semi-annually, so the effective annual rate is, so 5% per period, 2 of these periods per year. So the EAR is 1 plus APR divided by 2 to the power 2. So whatever we use to divide the APR here is the number we use as an exponent to compute the effective annual rate. So the effective annual rate here is 10%, 10.25%. So 10% in simple interest and 0.25% in compound interest. So more generally, if an APR is quoted as simple interest, the effective as simple interest given a compounding given m compounding periods during a year, the effective annual rate is 1 plus the quoted rate divided by the number of compounding periods during the year to the power number of compounding periods. And we need to subtract 1 because this number here is greater than 1. And we are looking for a number between 0 and 1. Okay, and this means that for a question on relating to this subject to be clear, each time an interest rate is announced, like 2 dimensions have to be specified. So the first is what are we quoting? So generally we will be quoting the APR, the annual percentage rate, or the simple interest paid during a year. And then we need to announce also the number of compounding periods during the year. So is interest calculated every month? Is it calculated every 6 months? Is it calculated every 3 months? So this is the second dimension that has to be specified whenever you read a question on this subject. So a firm is quoting an APR of X% compounded monthly. A firm is quoting an APR of 12% compounded quarterly. A firm is quoting an APR of 8% compounded semi-annually. So always blah 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 is quoting an APR of something percent. That's the first piece of information. Second piece of information, compounded periodically with what mentioning the period, the compounding period. So compare the following rates. So Bank A, 15% compounded daily. Bank B, 15.5 compounded quarterly, 4 times a year. And Bank C, 16% compounded annually. So the EAR of the deposit we could make in Bank A, or the EAR of a loan taken from Bank A, 1 plus 15% divided by 365 to the power 365 minus 1, 16.18%. So daily compounding with quarterly compounding and an APR of 15.5%. The EAR is 16.42%, and with an annual compounding and an APR of 16%, the EAR is equal to the APR of 16%. So there's no difference between the APR and the EAR when compounding is annual. Okay, some questions. Finding the APR from an EAR. A bank wants to grant a loan for which the interest rate will be compounded monthly. And the bank wants the loan to generate an EAR of 15%. So the bank has a goal in mind. The bank wants this product to produce an income, an effective income of 15%. So what interest rate should it quote on the loan? So you want 15% to be equal to 1 plus the APR divided by 12 to the power 12 minus 1. So we need to solve for APR. So that gives us an APR of 14.06%. So if the goal is 15 as an EAR, the APR has to be slightly below 15. So if compounding is greater than 1 during a year, the APR is always smaller than the EAR. What monthly interest rate, RM, provides an effective annual rate of 15%? Well, the same question. So we have 15% for the full year. That has to be equal to 1 plus the monthly rate to the power 12 minus 1. If we solve for the monthly rate, that gives 1.17%. What is the EAR of a 12% annual percentage rate compounded every nanosecond? So we have annually, if the APR is 12% compounded annually, EAR is 12, quarterly 12.55, 12.68. So the question is, will the EAR become infinite if we compound infinitely? That's the question, and the answer is no. The EAR always remains finite. So if we have an APR equal to Q, and we take the limit as the number of compounding periods in a year go to infinity. So 1 plus the APR divided by m to the power m. What happens when m goes to infinity? Well, this does not go to infinity, nor does it go to 0. So this converges to e to the power q. So e to the power q, that's the natural number. So it's, if I take 1, so 2 E is the 2.7182818 blah blah blah. Okay, so that's the inverse of the natural logarithm, and it's just a natural property of numbers. Okay, now so I'll stop here for the moment. Okay, so what have we seen in this session? The difference. What is an APR? APR is simple interest. Okay, remember with the P, APR, simple interest. Okay, maybe that may help. Effective annual rate. Well, the APR implies a rate compounded how many times a year. So I take the APR I divide it by the number of times it is calculated, like interest is calculated during a year. And my effective annual rate is 1 plus APR divided by the number of periods to the power number of periods minus 1. And that's my effective annual rate. Now from an APR, I can obtain an effective annual rate. And if I aim at an effective rate, at a given effective rate, but I need to quote an APR. So what APR should I quote given a rate? So this is what we have seen so far in this first portion of this lecture.